Hey everyone, welcome to Edureka. Now in today's session, we will see how we can make use of deep learning and detect the brain tumor. So this session, I would rate it as an advanced session. So I'll do my best to simplify as much as possible so that anyone with any level can get the overall idea as what we'll be doing, guys. So let's have a look at the agenda. Now, as part of today's session, we will understand what exactly is this deep learning, the general intuition behind this deep learning, and then we will see how we can process the data using deep learning, especially the image data, and we will look into the various scenarios. One is how we can perform the brain tumor detection using a custom model, and I'll also share you as how you can perform the transfer learning as well. And at the end, we'll also look into the CNN architecture and we will have a hands-on session. So I have a notebook which has been prepared for performing the cancer detection using deep learning. We'll have a walkthrough of that notebook so that you'll understand how do we get started with any deep learning code. All right, guys. So let's get started and let's start by understanding what exactly is this deep learning. Here, the reason that we would prefer to work with this deep learning because whenever there is a lack of domain understanding for feature introspection, that means whenever I'm not aware about the features that we have in the data set, that is the column or the features that we have in the data set. So the deep learning techniques actually performs pretty good in such scenarios because here in the scenario of deep learning, we don't have to worry too much about feature engineering. So all the features and the required adjustments will be taken care automatically with the deep learning neural networks. And even as the data size increases, my deep learning model actually performs better and better way as it starts getting more data, which is not the same with the traditional algorithms that we have. And that is the reason deep learning is being used in various domains. So it is used in complex activities such as image classification, natural language processing, speech recognition. So in all those areas, deep learning actually outshines the traditional machine learning approach. Now, in the scenario of this deep learning, guys, here, if I want to describe what exactly is this, deep learning is a branch of artificial intelligence. In order to analyze the data, it makes use of a structure that is called as artificial neural network, which has been created to mimic the way that we humans analyze the data. And that is the reason we observe and we see that the deep learning models performance actually performing really good compared to the other models. Okay, so that is one of the main thing about this deep learning neural networks. And when we are talking about this deep learning, if I want to give you a general intuition behind this deep learning, so this deep learning, as I mentioned, has been created such a way that to give us and to ensure that the data is analyzed just like we humans analyze the data. Now, if I want to help you in understanding how it actually does, okay, so just think about it. Our human brain has a brain cell. Now that brain cell is going to it is going to take our inputs from our sensory organs. It could be various sensory organs. Once it gets the input or once it gets the information through various sensory organs, the next thing it would do is it will send that information to my human brain. And once my human brain receives that information, so my human brain is going to give me the it will tell me as what I have to do. Okay, so that's what the general human brain is going to work in each and every human being. So we have constructed the neural network architecture in the backend such that we are going to mimic the analysis of the data in a same way. So to help you compare the single neuron and the single brain cell, okay, so let's say we've got a neuron. Okay, we've got a single neuron and this neuron receives multiple inputs. So here, just like my human brain have the dendrites, I have the input layer through which my neuron receives the input. And just like we've got nucleus to analyze the information that we receive from the sensory organs, So in the same way, we have a perceptron. So you can think of them as a perceptron. Just like nucleus analyzes data, here I'll also perform some kind of data transformation such that I'll be learning as much pattern as possible from the data set. And just like we've got axon terminals, which sends the output to the next neuron, here in my neural network, I've got the output layer, which sends that information, which is the processed information, to the next layer. So this is how we'll be working with the neural network. Basically in the neural network, it has the input layer, and we have got some processing layer which does some processing, and we've got the output layer. Now when I say processing, so it's basically the summation and bias term. So suppose if I have the inputs x1, x2, x3, x4, okay, if I've got four inputs as x1, x2, x3, x4, and its respective values of the weightage are w1, w2, w3, w4, at this step I'll perform the summation and I'll add the bias term. Summation is nothing but the dot product between my input layer and the weights. So that will be the summation. And on top of this summation and bias term, we are going to apply the activation. So we'll apply the activation. On that basis of activation, we are going to predict the output. And this activation is nothing but a mathematical function which converts the output that I'm getting from summation and bias term to the required range. And this is how the data gets processed in a single neuron. And the same process will get repeated for each and every neuron in my hidden layer. So this is an illustration of multi-layer perceptron. Now what happens in this scenario is, so it will get processed, we'll have an input layer and we have the multiple hidden layers. And just like we have seen the summation and the activation, the same thing will be performed in each and every neuron in this multi-layer perceptron. So this multi-layer perceptron is also called as deep learning neural network. Sometimes we also call it as feed-forward neural network. So these are the various terminologies that we might use, but it would mean the same thing. It's a series of neurons which are structured in multiple layers, and overall it will help us in analyzing the data. So that is what a multi-layer perceptron is. Okay, now when we have such kind of neural network architecture, whenever I want to analyze the data, suppose if I want to analyze the image data, then in such scenarios, one common issue that we would face is the issue with dimensionality. So when I say dimensionality issues, the number of dimensions that I have in my data set, it just explodes. So it just increases, and as a result of this, my system will go out of space when I'm doing the calculation, and sometimes I may not be able to reach the right value. So what happens in that scenario is, instead of learning the overall pattern, it will be forced to learn each and every feature as a separate instead of learning the overall pattern. And that is the disadvantage that we have when we talk about the artificial neural networks. So in order to help us in processing the image data in an efficient manner, we make use of a special architecture that is called as CNN, that is convolutional neural network. In order to help us to minimize this curse of dimensionality, we make use of this special layers, that is convolution layers, which will help us to analyze the data in an efficient way. Now, this series of convolution layers along with the dense layer, in total we call it as convolutional neural network. So a typical example of a convolutional neural network look like this. See, I've got the image on the left hand side, and on top of this image, I'm applying the various convolution operation. That means I'm applying multiple convolution layers. And once I apply the multiple convolution layers, I'm doing some sort of pooling. Pooling means reducing of dimension. Now, once that is done, I'm again applying the convolution operation followed by pooling, and this is followed by fully connected layers. And at the end, I'll have the output layer which will help me to predict the output. And this is how a typical convolutional neural network will consist of. I'll have the image, and this image is being sent like this. On this image, I'll perform the series of convolution operation followed by pooling, and at the end we'll have an output layer. So this is how a structure of my convolutional neural network would look like. So the way this data gets processed, in order to explain this, you can think of them as the template matching. It will do some kind of template matching, which will take the template and it will try to find whether the template is present. It means it is going to learn the patterns in the data. Okay, now once it learns the pattern, it will check whether that pattern is present instead of treating the individual feature as a own. So that is how the convolution neural network has a greater advantage while working on the image data. Now, while applying on this data set, that is on this overall data, okay, we've got convolution layers. So this convolution layer is also called as convolution filters. So what this is going to do is this convolution filter, this will have the, I can say like this will have some kind of data, and you can think of them as initialized set of weights. Okay, so using those initialized set of weights, I'm going to apply the convolution filters, which means I'll place this kernel from left to right and I'll move this kernel from left to right and top to bottom. And as a result of this, I will be getting the transformation of the pixel region. So this is what happens in the convolution filters when we apply it on the data set. So this filters will have some integer values, okay, or it can be floating values as well. So these are the parameters which we'll be finding once we train the model. So I'll initialize it to some values, and if I apply this layer on top of my image, I'll take the dot product between my kernel region and my image region, which will help me to generate the transformed pixel data. And this is the working of this convolution filters. Now, apart from this convolution filters, okay, apart from this convolution filters, there is one more layer that I'll be using, that's called as pooling layer. So this pooling layer will help me to summarize the data. Overall, the application of this pooling layer is to reduce the number of dimensions that we are dealing with. So here in this scenario, I've got my original images of the dimension 4 by 4. Now on this image of 4 by 4 region, I'm applying the pooling layer with a pool window of 2 by 2. And as a result of this, we are performing the max pooling operation and we are reducing the dimension by 2 by 2. So this is the working of this pooling layer. It will help me to summarize the data. One, I have the option of max pooling. The other option is I can make use of average pooling and get the average of each pool window. So that is the working of this average pooling. Next, we've got the layer padding. Now here in this layer padding, we add this dummy layer so that it will help us in capturing the same image shape even after we apply the convolution operation. And that is the best part of applying the layers padding. So by adding the padding to my layer, I'll ensure that my individual layers, when it goes through, I mean, when that image data that it goes through this individual layers, so the dimensions will not get reduced. So this is the operation of this layer padding. Now, once I perform this series of convolution and pad pooling, series of convolution pooling, at the end, before I send it to my dense network, I'm going to perform the flattening operation. Here, the flattening operation is nothing but converting the multidimensional tensor representation into a single dimension tensor representation. So that is the working of this flattening operation. Flattening operation helps me to convert the data which is in multiple dimensions into a single dimension. So overall, if I consider my convolution neural network, the various components of this convolution neural network are image data, and on this image data, I'll apply a series of convolution layers, and on top of this, we'll apply the max pool layer, and on top of this, we'll have series of convolution max pooling, series of convolution max pooling. At the end, I will have a flattened layer which will help me to convert the data which is in multiple dimensions into a single dimension. And this flattened data is connected to a dense layer, which overall helps me in getting the image features and also processing with the help of dense network. And at the end, we will have an output layer. So this is how a typical structure of this convolution neural network. Okay, now in our activity, we'll be performing the tumor detection using convolution neural network. Now, as you have clearly seen, convolution neural network is one of the most widely used neural network, especially while working on the image. And an, being this an important topic, which is very close to the industry working. So if you're someone who's serious about deep learning, I would recommend that you follow an approach in overall deep learning journey, a structured learning approach. Now, a structured learning approach is a learning approach which will be recommended by industry experts, which will ensure that you're going to cover all the important topics and you will learn in a specific order. In order for you to understand how does a structured learning at Edureka would look like on this deep learning certification training course, here in the module 1, you will have an introduction to deep learning. And in module 2, you'll get started with TensorFlow, which is one of the most widely used library when it comes to creation of deep learning neural networks. And module 3, it's about working with convolutional neural network. And module 4, it's about regional CNN, which will help us to identify the objects in an image. And module 5, it's about Boltzmann machine and autoencoders. And module 6, it's about GANs, that is generative adversarial network. And module 7, it's all about emotion and gender detection. And module 8, it's about introduction to RNN and GRU. And module 9, it's about LSTM. And in module 10, so it's about auto image captioning using CNN and LSTM. So this is how the overall learning journey would look like in this deep learning certification training course. Okay, so I hope you remember this. It's very important that when you join any learning sessions, or whether it is you who is doing the self learning, it is recommended that you follow this approach so that you get the best in your learning journey that you'll have. Okay, now coming to the next topic, we've got transfer learning. Now transfer learning is a scenario. Okay, so transfer learning is a scenario where I'll be using the learning. So when I say using the learning, it's about, let's say if I've done a training on a specific data set, I can use that learning which have been done on the previous on a different data set and use it for our task. And that is what a transfer learning approach would mean. It's an improvement of learning in a new task through the transfer of knowledge from the related task which have been already learned and done. So that is what it means by transfer learning. Here in a traditional approach, suppose if I have a data set 1, I'll train my model, and if I have a separate data set, I will just train independently on the second data set. So that is a general approach. Now when it comes to transfer learning, here we will be using the data set 1. I'll be building the machine learning model 1. Now after that, I will use whatever the learning that I had, I'll use that knowledge and I'll apply it on a different data set. And that is the working of this transfer learning approach. And this is one of the advanced approach. So this will help you to prepare yourself, and this will help you to apply the model, reduce the training time, and help you to achieve better accuracy. So that is the advantage of this transfer learning approach in deep learning. Now, when it comes to transfer learning, as I mentioned, I'll be using the pre-existing models or someone's trained model. So each and every model will have its own architecture. So each and every model will have its own architecture. So if I want to represent that architecture, okay, so there are various model architectures, guys, which have been trained on the various data set. So here in this scenario, so one such model architecture that we have got is LeNet architecture. Okay, so this is called as a LeNet architecture. where I have the series of convolution layers, and this gets the input of the shape 32 by 32. And another well-known architecture is called as mobile net model architecture. We've got a ResNet, InceptionNet. Like that, we'll be having multiple such kind of architectures that are available. You can check out the official page of TensorFlow to know the various pre-trained models and how you can work with the same. So now that you have the high level understanding on this deep learning neural network, let's work on this in a hands-on manner. Okay, as I mentioned, I have the code written and we'll have a demonstration of the code, and I'll explain how we are performing the task. So here in the first cell, I'm importing the necessary libraries, and more importantly, this is a cell where I'm downloading the data set and I'm performing the unzipping. Okay, now once I download the data set, in this cell, I'm loading the necessary libraries. So this will load the necessary libraries. Now, once the libraries have been loaded, I'm going to split the data set. Okay, so here I'm just counting as how many number of images that we have for brain tumor and healthy, and we will split the data in this 70 15 15 percentage, and this is a cell which takes care of splitting the data into train and test and the validation. Okay, now once this is done, we are going to import the model. Okay, we will import the various model here. When I say model, currently right now we will be building this model from scratch, hence I'm importing the necessary libraries, and in the below cell I'm building my model as a sequential model. So once I create it as a sequential, for this model I'll add the respective layers. So I'm adding a convolution layer with 16 filters. Here I'm saying that kernel size has 3, 3, which means each filter or a kernel has the shape of 3 by 3, and the activation is ReLU activation function, and it expects the input which is of the shape 224, 224, 3. Okay, and we've got convolution layers which is 32 filters, and the kernel size is 3, 3, and the activation is ReLU, followed by max pooling layer, convolution layer, max pooling layer. So as I mentioned, we'll have series of convolution and max pooling layers, and at the end we have the dropout layer, and finally we have a flatten layer. Okay, and then see, we have got the dense layer, and at the end I'm having a single neuron which is acting at the output layer. Now once we build a model, we are going to compile the model. This is one of the mandatory step, because this is the one which tells my model as how the training should proceed, and while training, what is the loss function that I have to use, and what is the learning algorithm that I have to use. So we will build that model. Now once the model has been built, so I think you can ignore the step since we have done the compile already. Next here, we are going to prepare the data by creating the data generator, and we will specify how to load from the directory. So this will tell my system as how it should load from my folders. Okay, now after that, in this cell, we are going to define the early callbacks. So especially the early stopping and the model checkpoint, these are the callbacks that we have. Okay, so we will call these callbacks, and we use these callbacks, and we will create it and we'll use it during the training. So that is the usage of keras callbacks. So this will create the keras callbacks, and after that we will perform the fit on our data set. So this will perform the fit on our data set. So this would take a while because we've got a lot of data set, and the data set, like each and every image, I'll have to process it. So here, in order to ensure that we complete it as soon as possible, I'm just saying it as steps per epoch as 8. Okay, but if I train it on my entire data set, that would still take more time, guys. Okay, let's wait for the training to complete, and once the training is complete, we are going to load the best model, because currently during the training period itself we are saving the best performing model. Now once that is done, we can go ahead and overall print the accuracy. So let's wait for the train to complete and display the accuracy right now. Okay, so it looks like it is working fine. And if we go ahead and look at the accuracy on our data is 76%. That's great. Now let's create the visualization and see how does the training has been progressed. So we can clearly see that as a model training progress. So this is how the overall training would look like. Okay. And if I look into the accuracy loss, with the each and every number of epoch, the value of loss is also decreasing. So this is what we were able to see on our data set. Now let's get our data. Okay, I'll just load one of the data over here. Okay, maybe I'll pick up one of the data. Okay, I'll copy path and I'll paste it over here. And if I execute this, okay, so I've got a output that says, okay, so let me print the print. Okay, let me see, print bread. Okay, it is 0.323. Okay, I'll have to check right now whether my bread is greater than 0.5. Okay, if it is greater than less than 0.5, then the image is a brain tumor, else it's a healthy brain. So let's just validate it. What is the class values? So this will ensure that we are writing in a correct manner. Okay, healthy is 1, brain tumor is 0. So the whatever the logic that we have mentioned, it is correct. If my value is 0 less than 0.5, it is a brain tumor. That means it belongs to cancer. Else it is a healthy brain. So I gave an example of an image which contains the cancer, and my model is predicting that the MRI image belongs to the brain tumor. So this is what we have been able to do by implementing the deep learning neural networks, guys. We have used the data set, and once we have loaded the data, we have created our model as a sequential model, and we started adding the individual layers for that model. And once we stacked the individual layers, the next thing that we did was we have performed the training. Okay, so once the training is completed, okay, once the training is completed, the next thing that we are doing is we are generating the prediction, and we tested on the validation data that, okay, if I give an input of the cancerous image, so I'm getting the correct output that says as, okay, this MRI image is of brain tumor, which means the program is working as expected. Okay, so with this, we come to the end of this today's session, guys. Thanks a lot, team. So I look forward to seeing you next time. Take care.